Assalamualaikum warahmatullahi wabarakatuh. In this video, I will be presenting the simulation and the explanation on the inside of the uh, data set of this code. The context of predicting the diabetes. The code performs several steps to train and evaluate the classifier, tune hyperparameters, and analyze the model's performance. So here is the breakdown of the code. So the first one is importing the required libraries. Importing the necessary libraries including the scikit-learn, Catboost Classifier, Pandas, NumPy, and visualization tool like the matplots and Seaborn. It also suppress warnings for cleaner output. And also the reading the dataset from the Kaggle input, which is the diabetes.csv file, and reading the first 5 row of the data, the code diabetes.head, and also diabetes.info, which is showing some information about our dataset, and data.describe, showing the count, the mean, the standard deviation, the mean, and the maximum in our dataset. Like for example, the age. So the minimum age in our dataset is 22 and the maximum age is 93, and the mean age is of our population is 48. So that is for data describe. And then the next is the correlation matrix. So printing the correlation matrix, which is showing that the age is correlated into the more correlated into the age of a person, which is the diabetes. There is a high probability that the person can have a diabetes if they have much more years or higher age. And then the next is splitting the data set. So data is for the data preparation, which is in splitting. The data set is split into features, the X and the target variable 1. So the train test split function is used to split the data into training and validation set. And then the next is the data scaling. The training features are scaled into standard scaler from scikit-learn. The scaling helps in normalizing the features to have zero mean and unit variance, which can improve model performance. The hyperparameter grid definition. A grid is hyperparameters is defined for the Catboost classifier, and this grid includes options for iterations, learning rate, maximum depth, L2 lift, regression, and RSM. And so that is for the hyper parameter. And next is the defining the model. And an initial Catboost classifier model is created with default parameters. The grid search for hyperparameters tuning, grid search SB, is used to perform a grid search over the defined hyperparameter grid. The best combination of hyperparameters is chosen based on the choose validated performance on the training data. And then and also printing the best hyperparameters. The best hyperparameters found through grid search are also printed. prediction on the validation set, the area under the ROC curve, the ROC is also calculated. And also the confusion matrix. The classification report metrics, sensitivity, specificity, and F1 score are computed and are printed to further evaluate the model's performance. The precision, the recall, F1 score, and the support. And also visualization of the confusion matrix. The confusion matrix is visualized using a heat map created with the Seaborn library. And so this code is essentially demonstrate the process of hyperparameters tuning, model training, evaluation, and visualization for Catboost Classifier using a diabetes dataset. It is a comprehensive example of building and assessing machine learning model for binary classification. From the provided dataset and program, we can gather insight about the process of building and evaluating a machine learning model for predicting diabetes. So let's summarize some key insights. Data pre-processing and splitting. The dataset is split into features and target variable diabetes. The features are scaled using a standard scaler to ensure consistent scaling across the dataset, which can improve the model's performance. The hyperparameter tuning. The program demonstrates the importance of hyperparameter tuning using a grid search approach. It searches through different combinations of the hyperparameters to find the best set that maximize the model's performance in cross-validation data. And also the model training and evaluation. The Catboost classifier is used for binary classification and it's trained on the skilled training data. The model's accuracy is evaluated on both the training and validation sets. Cross-validation provides a more robust estimation of the model's performance. So overall, this program showcased the systematic approach to building and evaluating a machine learning model, particularly using the Catboost library. The inclusion of hyperparameter tuning, performance evaluation metrics, and visualization provides a comprehensive view of a model's capability and limitations in predicting